For 8 days straight, a warship had no idea it was being followed. Active sonar, full power, pinging the ocean every few seconds, random course changes every 3 minutes, a helicopter on the flight deck, armed, fueled, ready to launch, and somewhere beneath the surface, a submarine was watching all of it, patient, silent, invisible. This is how modern submarine warfare actually works. And understanding it changes how you see every naval conflict happening right now. To understand why a submarine is so hard to find, you need to understand one thing about the ocean that most people never think about. Sound does not travel in a straight line underwater. Water has layers, warm water near the surface, cold water below, and at the boundary between those layers, called the thermocline, sound bends. It curves downward away from the surface, like light bending through a prism. A warship on the surface, sending sonar pings downward, hits that boundary, and the sound curves away, painting an empty ocean on the screen, even if a submarine is sitting right below it. That boundary is the submarine's best friend. Sit below it, move quietly, and the ocean itself hides you. This is why modern submarines operate at what sailors call operating depth, deep enough to sit beneath the thermocline, deep enough to be invisible to surface sonar, deep enough to hunt. But hunting requires more than hiding. It requires knowing exactly where your target is. And this is where the physics of sound underwater becomes a chess game. A submarine tracking a surface ship uses passive sonar. It listens, but never transmits. No pings, no signals, nothing that would reveal its position. Instead, the submarine listens to the sounds the surface ship makes. Engine hum, propeller cavitation, the specific acoustic signature that every ship produces, as unique as a fingerprint. But listening tells you direction, not distance. You know the ship is somewhere to the north. You do not know if it is 2 miles away or 20 miles away. To solve that problem, the submarine uses a technique called target motion analysis. The crew takes continuous bearing measurements, the direction of the target, and feeds them into a targeting computer. As the submarine moves and the angle to the target slowly shifts, the computer builds a mathematical model. Speed, course, range. A firing solution that becomes sharper with every passing minute. It is like triangulating the position of a moving car by listening to its engine from 2 different street corners. Each measurement alone tells you nothing. Together, they tell you everything. The surface ship knows this, and it fights back. Random course changes reset the calculation. Every time the ship turns unexpectedly, the submarine's targeting solution collapses. The crew starts over, new measurements, new model, minutes of work erased in seconds. The helicopter on the flight deck is the other weapon. The thermocline that protects the submarine from surface sonar has one weakness. A helicopter can lower a sonar transducer on a cable directly through the thermocline into the same acoustic environment the submarine is hiding in. Think of it as hiding behind a curtain while someone walks around to your side of the room. The moment the transducer drops below the thermal layer, the submarine's hiding spot becomes an auditorium. One competent helicopter crew, leapfrogging across the ocean, can search a box of water faster than any surface ship, and the submarine knows it. So the submarine watches the helicopter. It listens for rotors spinning up. It calculates how much time it has before the search pattern closes in. And then there is the problem that every submarine commander dreads: getting the order to act. A submarine at operating depth cannot receive most radio signals. Water absorbs electromagnetic waves. The only signals that penetrate are extremely low-frequency transmissions called ELF, a technology so limited it can send only a handful of characters per minute. It is enough to say, "Come to the surface and get your orders." It is not enough to transmit the orders themselves. To receive an authorization, the submarine has to rise through the thermocline into the water column where surface sonar works. It must get close enough to the surface to raise a communications mast above the waterline. For a few seconds, the submarine is exposed. Modern submarine crews have developed techniques for this moment. They look for large ships nearby, tankers and container vessels, and use those ships' massive radar returns as cover. A periscope mast appearing briefly in the radar shadow of a 200,000-ton tanker looks like background noise. A ghost return, not a submarine. The geometry has to be perfect. The timing has to be exact. It has to happen in seconds before the exposure window closes. This is the cat and mouse game that plays out beneath the surface of every major naval conflict. A submarine that stays deep is safe but blind to orders. A submarine that comes shallow to communicate is vulnerable. A surface ship that uses active sonar reveals its position and invites the submarine to track it. A surface ship that goes silent loses its ability to detect what is hunting it. Every decision trades one vulnerability for another. And the physics of the ocean, the thermocline, the sound channels, the convergence zones where acoustic energy bends back to the surface 30 miles from where it started, all of it shapes what is possible. Modern submarines are quieter than ever. Their propulsion systems produce almost no cavitation. Their hulls are coated in anechoic tiles that absorb sonar pings rather than reflecting them. A modern nuclear submarine moving slowly is, for practical purposes, a hole in the water. Detecting them requires not just good sonar, but a network. Towed arrays, cables of hydrophones trailing hundreds of meters behind ships and submarines can hear sounds at ranges no hull-mounted system could reach. Sonobuoys, dropped by aircraft, listen passively and relay data back. Fixed arrays on the seafloor monitor entire ocean corridors around the clock. Anti-submarine warfare is not one ship hunting one submarine, it is a system. Sensors, aircraft, surface ships, and other submarines working together to shrink the ocean until there is nowhere left to hide. The next time you see a naval conflict in the news, remember that the most important part of it is the part you cannot see. Not the ships on the surface, not the aircraft overhead, the submarines beneath the surface moving slowly. Listen to everything, waiting for the geometry to solve. The ocean is not empty. It is full of hunters, and the best ones are the ones you never know are there.